You're looking at a grass in front of our vacation home in Croatia, and you can see the grass is pretty dry due to the heat. This summer was actually one of the hottest in terms of temperatures and drought. But if you watch the news, after the dry period came the rain and many floods were reported. This happened in major cities of South Korea, Italy and Croatia, which are built on a concrete platform, but also in Pakistan, where the villages are on top of bare soil. And this was strange to me, because I always thought if the soil is so dry, wouldn't it absorb every single raindrop? But then I came across a video of Dr. Thompson, a meteorologist from the University of Reading in the UK, who carried out an experiment using 3 upside glasses of water on different grass surfaces. So wet grass, grass during a normal summer and grass after a heat wave. And he observed how quickly each of them would drain. Surprisingly, the dry soil absorbed the water at much slower rate, but people in the comments weren't convinced and were saying that it was tested at 2 different places with different soil composition, that the ground was not flat, that there were grass blades in the way which caused the leakage from beneath the cups, and so on. So during the holidays in Croatia, I had some time and tried to recreate the experiment in a way that it would tackle all the problems and allow for unbiased comparison of the water drainage between the wet and dry soil. For the experiment, I used plastic bowls used for Chinese food and made an opening in the bottom for the drained unabsorbed water. To prevent differences in soil composition, I filled the bowls with plain gardening soil. Each bowl was completely filled to the top and the soil was stepped to ensure a flat surface. The bowls were labeled with 100%, 20% and 0% based on the amount of water received. 100% soil was completely wet. In 20% soil, water created a wet soil channel from top to bottom, and 0% soil was completely dry. The soil was placed on top of a glass to catch drained, unabsorbed water. The water was introduced in a champagne party glasses, which were placed upside down on top of each soil. The time for the water to drain was measured, as well as the amount of drained, unabsorbed water that ended in a glass below. And this is how the first experiment went. In case of 100% soil, which was completely wet, the water drained from the cup the fastest, followed by 20%, while the water on top of dry soil, labeled with 0%, drained the slowest, and it actually took almost 4 minutes for the whole process, so I had to speed up the video. Beside different times for the water to drain, there were also differences in levels of drained unabsorbed water in glasses below. Then I simply used tape and marked the height, so from the top of the glass to the water surface, and from the diameter of the glass I calculated the volume of drained unabsorbed water in each glass. I repeated this experiment 8 times, but 3 times it was a failure. I really didn't thought that placing cups on top of a soil would be that hard. In some cases I lost some water, I disturbed the soil, or the cups were tilted, and in the end I was left with 5 good repetitions. So let's take a look at the results. First, the graph for drained unabsorbed water, which is the most predictable factor in this scenario. As you can see, in case of 100% soil, which was completely wet, all the water in the cup drained through the soil and ended in the glass below. However, in case of 20% soil and 0% soil, almost half of the water in the cup above was absorbed by the soil itself, and only half of the water drained in the glass below. So even though 20% soil was wet, it still had the same capacity to absorb water as the dry soil labeled with 0%. This water drainage effect is what actually one would expect based on different wetness of the soil. But what about the time? Well, here it gets interesting. In case of 100% soil, the average time for the water to drain was 50 seconds. In case of 20% soil, the average time was 75 seconds. And in case of 0% soil, which was completely dry, the average time was 150 seconds. So basically, in this experiment, the dry soil drained the water 3 times slower compared to the wet soil. Another interesting fact to point out are also similar water drainage times of 100% and 20% soil, which means that the small amount of water present in the soil can accelerate the water drainage. But in this experiment everything was controlled, so I had to test it also on real-life situation. For this I mowed 2 patches of grass, but because there was no rain for weeks, both of these grass patches were dry. But then I soaked one of the grass patches using large amounts of water, and this patch represented wet soil, while the other one was left intact, and this one represented dry soil. So in this case I had in theory 2 soils with the same composition, but only completely wet one and a completely dry one, and nothing in between. For this experiment I also used heavier glasses so that they could be firmly placed on the ground. But of course this time I couldn't measure the amount of drained unabsorbed water, but only time for the water to drain. From the graph you can see that there are only 3 repetitions for each wet and dry soil, and that's because the failure rate in this experiment was even higher than in the first one. The main problem was indeed the leakage of the water from beneath the glass due to the grass blades. But despite this you can still see the tendency of dry soil having slower water drainage effect compared to the wet soil. And this means that it's also applicable in real-life situation, even though it's harder to replicate it. I hope this simple experiment showed that dry soil can affect water drainage and could potentially lead to flash floods. But in real-life situations, I think that everything needs to come together. Heavy rainfall after a heat wave in a short period of time, and the composition of the ground needs to be really compact, and this all calls for a disaster. And with that, I would like to thank you for watching, and I'll see you in the next one.